Hi everyone, this is Tim here at Makers Machining. I got a little project here I'm going to do this morning for you, and I was thinking a little bit after I accepted the job. I quoted it and accepted it. I thought, boy, this might be tougher than it planned out to be. But what I've got to do here, I've got these bolts. They're a metric bolt, and the customer needs them to have more thread. It's got a 35 millimeter thread. That's the maximum they generally make. They need 45 millimeters of thread. So I was thinking, what's the easiest way to do this? I got a box full of them to do, and so I wasn't sure exactly the best way to go, because these are grade 8 is the English version of toughness on the bolt, but this is a 12.9 DIN, D-I-N. That's how metric classifications are, and that's the toughest grade that you can get. So I thought, boy, I don't want to single point these threads, because that would take forever. You'd have to pick up the exact thread pitch and the thread before you could machine them. So I'm here and thinking, how am I going to do this? So I figured, well, at least I know I'll have the exact right thread. I'll get a couple of these thread chasing dies here, and we'll see if we can run the screw through them, or run the die on the screw. Or the bolt. Anyhow, I thought, well, I've got this hexagon shape here, which would grab nicely in the chuck. So what I'll do is I'll put one of my bolts in there, and it's a snug fit, so I know I got a good fit on it there. And then in my tailstock, I put a chuck in there that would grab the head of the bolt, just enough to grab it there, and I'll tighten it down there, and that'll hold the screw or the bolt from turning while I'm cutting the thread. Now, you got to think about this. On a bolt like this, the way they're made is they're made on a header machine and a threading machine. They'll take a metal rod this diameter off of a coil, and then they'll pound the head on it until they get the shape of the hexagon wrench to fit in there, and the head, which is a certain diameter, and there's some little grooves on there for helping you grab it when you turn it. But the end where the threads are is smaller than the rod diameter, but it's bigger than the root diameter of the smallest diameter of the threads. It's halfway in between, roughly. And so they use these heading machines to pound the head on there. It probably also sizes the rod small enough there. And then as they make these bolts, they drop them through a series of 2 plates that have the thread shapes on them. They just roll the threads. And you can see here how they roll the thread. The diameter starts from the rod diameter here, it drops down, you can see where the angle is, and then the threads, the way they set this between the 2 plates to roll it, the threads stop right at where the smaller diameter is. And then they compress and upset the metal to make the thread. They don't cut these threads, they form the threads, which gives you a stronger thread, because you're compressing the metal, you make it stronger, and it gives you a nice shape. If you measure this is I believe it's a 12 millimeter screw. I'm sorry, it's a 10 millimeter screw with a 1.5 millimeter pitch. That means there's 1.5 millimeters between each thread. If you convert that to inches, that's about 60 thousandths. 1 millimeter is just a hair under 40 thousandths, so 1.5 millimeters thread pitch would be just right at a 60 thousandths roughly. So that's almost a 16th of an inch. But anyhow, they roll form those threads and get them on there good and tough. So this being a hard, tough alloy, I wasn't sure how good these threading dies would work, or even if they would last. So I bought a few of them, like I said. So if I have one that seems to be getting a little dull, I can switch it out. I also bought one of these split dies here that would go in a die stock, they call it, where you hold the round die in there. There's some set screws to hold it in, and you can adjust the gap there so you can make the threads according to the right fit. But these chasing dies are called, have the right diameter on the threads, or the right pitch size and everything. So anyhow, I've tightened this thing in here. I'm going to run my lathe at the slowest RPM when I cut the threads, but I'm going to run it at a faster RPM so I can get it up the screw a little faster. I think I've got it in the I'm going at 72 RPM right now, and then I'll drop it down to 40 RPM when I do the actual cut. You might notice on one of the jaws here I put a marker on there, because I've got to have this thing, once it starts cutting, I'm going to count how many times around it goes to get my extra 10 millimeters of thread. 10 millimeters is roughly 3/8 of an inch. So I need to go around, about 10 times to get that. So I'm going to be going slow enough, I'll be able to count how many revolutions I've got, and maybe go an extra one just to make sure we get it to cut. I hope you can hear it while it's cutting, because the lathe is going to make a little noise here. But I've got it set there so I can run it in there. I'm going to turn this thing on, and my tailstock is not locked to the bed of the lathe. It's going to just slide along as the thread goes into the die. It pulls the tailstock along. My bedways are nice and smooth. They're parallel with the spindle, so everything lines up. This is also the way you tap under power. You drill a hole, put a tap in the chuck, and then you push in until it starts cutting its own thread. It pulls the tailstock in. Same thing here with chasing this thread and then cutting the new thread. So I'm going to put some tapping fluid on here, just so we've got some assistance for the cutting, because we're cutting some tough material here. I've already cut about a dozen of these things here, but let's run this thing up close to where the threads have to start, and then we'll go into the lower speed. Going backwards. We're going to turn it the right way, otherwise it'll unscrew instead of screw in. I start the screw in there. You can see it's not cutting anything, but it's just taking some of the black oxide coating off of there. Okay, I'm up close to where I want to start cutting my thread, so I'm going to switch gears over to I went from 72 RPM to 40 RPM. So now I'm going to run this thing in. When I see it starting to cut, I'm going to start counting revolutions. Okay, it started to cut. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll shut it off. We've got 11 revolutions there to cut that off. So I'm going to put it in reverse just to, it kind of breaks those chips off. Once it's broken the chips off from the cutting, I'm going to kick it back into the higher RPM so it unscrews faster. While it's unscrewing here, I'm going to take my air gun and blow off some of the chips. Blow the chips out of the die and off the screw. And when I get to the end here, I've got another inch to go. I'm going to turn this spindle off, because right now, you might have noticed it's pushing the whole tailstock and everything back. I'm going to loosen up the chuck here, and I'll just push it right off of there. Now I can manually take that out. The screw got a little warm there. It also has a little bit of a burr there, so I'm going to just do a quick spin around on there to take any of the sharpness off of those threads. So what I thought maybe would work or maybe not, it's worked for me. So I've got, you can't even hardly see where the threads start and stop. Close up here you can see the different color, but I gained a good half inch of thread there. So customer needs a minimum of 45 millimeters of thread. It was 35. Now we're good with the longer thread. So anyhow, I just wanted to show you how I went about doing that. I wasn't sure if it would work. I got the threading die and the die stock handle to maybe work there, but anyhow, just after going through a few steps and wondering if I gave myself enough time with what I quoted to do this, I think it worked out. I had to buy a few dies here just in case, and I'm not even close to the end, so it may or may not make it. So anyhow, just wanted to get back with you here with a little video from Maker's Machining. We'll probably have a few more coming out before too long again, so good talking with you again. So long.